So here's our next examples. We have f of x equals 3x plus 2 over x plus 5. We want to find the limit as x approaches infinity of f of x, the limit as x approaches negative infinity of f of x, and the limit as x approaches negative 5 of f of x. So if you haven't gotten a chance to do that, you should try that now. Pause the video and try it now. Okay, so hopefully you've had a chance to try it. So what we're going to do to look at limit as x approaches infinity is that's a horizontal asymptote. So we're just going to look at the degrees of the numerator and denominator. So I can see that the degree of the numerator and denominator is each 1. The degrees are equal. Therefore, I'm doing ratio of the coefficients. That ratio of coefficients is 3 over 1. Therefore, the limit as x approaches infinity of f of x is 3. And likewise, the limit as x approaches negative infinity of f of x is 3. As long as you've got a horizontal asymptote, both those limits as x approaches infinity and negative infinity are going to be the same for a rational function. There's lots of other functions that could have a different asymptote as you go in different directions. Maybe we'll see examples later. So now we want limit as x approaches negative 5. So this is now not approaching infinity, so it's not a horizontal asymptote. So if we think of limit as x approaches negative 5 of 3x plus 2 over x plus 5, we want to be thinking factor, simplify, substitute. Or could I just substitute first? Can I just substitute in the negative 5? No, because I'll have negative 5 plus 5, 0, and the denominator can't do that. So now I need to see if I can factor. Well, there's nothing to factor and there's nothing to simplify. So since I can't do any of those things, I have to just really look at the vertical asymptote. X approaches negative 5, that's a vertical asymptote. So I'm going to need to think about this graphically. So to think about this graphically, I'm going to think that I have a function that has a vertical asymptote at x equals negative 5. So here's negative 5, and here's a vertical asymptote. Now, if you really understand multiplicities, you can get this very easily, because since this factor is to the power of 1, that's an odd multiplicity. That means that whatever else is going on with this function, like I could go and find the x-intercept and the y-intercept and the horizontal asymptote, but you don't need to answer this question. You can just say, since the asymptote has odd multiplicity, either it goes up on the right and down on the left, or it goes up on the left and down on the right. It has to do one of those two things. It cannot go both directions. So either the function is doing this or it's doing this. Now I could figure out which one by plotting the x-intercept and the y-intercept, but I don't have to, because I already know that either the limit from the left is negative infinity and the limit from the right is positive infinity, or the other way around. Either way, this limit does not exist because the limit as x approaches negative 5 from the right of f of x does not equal the limit as x approaches negative 5 from the left of f of x. So the two one-sided limits are not equal. Whichever way it goes, they're not equal. So I don't even have to know what those limits are. I already know they're not the same. Therefore, the limit as x approaches negative 5 does not exist. Okay, so we had to think about that graphically, thinking about a vertical asymptote, because the limit was potentially infinite. Now let's look at the next example I have here. So now I have f of x equals 2x plus 5 over x squared plus 6x plus 9. I want the limit as x approaches infinity, limit as x approaches negative infinity, limit as x approaches negative 3. Please pause the video and see if you can find out what those values are. Okay, so now that you have paused the video, you've come up with your own values. Let's see what we can figure out together. All right, so first of all, when we look at the degrees, we can see that the degree of the denominator is higher. When the degree of the denominator is higher, you have a horizontal asymptote at y equals 0. That means the limit as x approaches infinity is 0, and the limit as x approaches negative infinity is 0. All right, so that's those two. We can get them very quickly. Now, for limit as x approaches negative 3, we're going to have to think about it a little harder. First of all, could I just plug the negative 3 in? Well, I'd have 9 minus 18 plus 9. That's 0 in the denominator, so I cannot do that. So I need to look carefully and first say, can I factor it? So I have limit as x approaches negative 3. So you can factor the denominator. When you factor the denominator, you're going to get x plus 3, x plus 3. Crucially, you want to write that as x plus 3 squared, because that squared is the multiplicity. That means this time I have an asymptote with even multiplicity. So that means either both sides are going to go up or both sides are going to go down. In either case, both limits from the left and right are going to the same value, either positive infinity or negative infinity. So I already know this value, this limit exists. So I don't get to quite cheat as much as I did on the previous one of not even bothering to graph it, because I need to know whether I'm going to positive infinity or negative infinity. All right, so let's see how we can graph this function quickly and find that out. So I know I have my vertical asymptote at -3. So there's my vertical asymptote at -3. And then the only thing other thing I need to finish the graph is the x-intercept and y-intercept. By the way, I should also, take advantage of the fact that I know that the limit in both directions is 0. That means I also have a horizontal asymptote at 0. All right. If I set the numerator equal to 0, I get x equals -2.5. That's my x-intercept from the numerator. So I have -2.5 right there is my x-intercept. I'm not even going to label it. And then for my y-intercept, one of my favorite tricks is I want all the x's to be 0. So I can just cover them up, and I can see that the y-intercept is going to be positive 5/9. And now, I don't have to be exact about that. The only thing that's important is that it's positive. All right? Now, to sketch the graph, just start from your y-intercept, go to your x-intercept. This x-intercept is coming from an odd multiplicity because the exponent on this factor is odd. That means we pass through. If I had an even exponent, I would bounce back up. It's an odd exponent, it's odd multiplicity, so I'm going to go back down. Now, this is a vertical asymptote of even multiplicity. So that means I'm going the same direction on both sides of it. That's because of the squared right there. Now on this side, there's no x-intercepts. I just have to approach the horizontal asymptote. By the way, I now know the limit, and I know everything I need to know. But just for the sake of completeness, let's think about the other side of the graph. Well, it has to come back down to that horizontal asymptote. So this is what that graph looks like. By the way, this y-intercept does not have to be the maximum. We could keep going up and then go back down. But we do have to eventually go back down. Or we could have peaked in here and then popped down. But this is sort of the simplest way you can draw that graph. And we have the important information that on the left and the right, both sides, the y values are going to negative infinity as the x values approach -3. So as the x value is getting closer and closer to -3, the y values are plunging down to this negative infinity. So that's how we know that the limit as x approaches -3 of f of x is negative infinity.